All right, today we're going to dive into a totally fascinating process that keeps us safe every single day. It's called bleeding time. I mean, this is your body's first line of defense, and it's working all the time, completely behind the scenes.
I mean, have you ever really thought about this? You get a tiny paper cut, right? And what happens? A few minutes later, it just stops bleeding. We totally take it for granted. But it's not magic. What's really going on is your body launching this incredibly fast, super coordinated emergency response. So that emergency response, it has a name. It's called hemostasis. This is literally your body's built-in system to stop you from bleeding out. It's what turns a potential disaster into, just a minor annoyance. It's a tiny miracle, really, and it all happens in 3 key stages.
Okay, so what are those stages? Well, first, the blood vessel itself literally clamps down. Think of it like pinching a leaky hose to slow down the water. That's called vasoconstriction. Then, almost instantly, these tiny little cells called platelets rush to the scene. Their job? To form a temporary plug, like a quick patch-up job. And finally, the body starts the slower process of building a really strong, durable clot to seal the wound for good.
To really wrap our heads around this, let's use an analogy. It actually makes it super clear. So imagine the platelets, those first cells on the scene, are like the first responders. They're the paramedics, right? They show up instantly to stabilize everything. But that whole coagulation process, the part that builds the final clot, well, that's the repair crew. They're the engineers who come in later to build a permanent, solid fix. And this analogy brings us to a super important distinction. Bleeding time, well, that's all about the first responders. It's measuring how fast those platelets form that initial plug. But clotting time, that's totally different. It measures the repair crew, how long it takes to build that final, sturdy seal. See, they're 2 completely different jobs. So if we want the official definition, bleeding time is just the time it takes for making a small, standardized cut on the skin until the bleeding completely stops. It's a direct test of those first responders, the platelets. Are they getting to the scene on time? Are they working the way they're supposed to? That's exactly what the bleeding time test is designed to find out. Okay, so that's the what. But what about the how? How did doctors actually measure this? Well, it turns out to be a pretty straightforward test, and there are a couple of common ways it's done. Yeah, the 2 main methods you'll hear about are called the Duke's method and the Ivey's method. They're both trying to do the same thing, but they go about it in slightly different ways. So, what's the difference? Well, with Duke's method, they'll usually do a little puncture on an earlobe or a fingertip. Super simple. Ivey's method is a bit more involved. It's done on the forearm, and they use a blood pressure cuff to keep the pressure consistent, which makes it a bit more reliable. The normal times are a little different for each, but at the end of the day, the goal is exactly the same: time those first responders. But no matter which method they use, the basic steps are pretty much the same. First, they clean the area. Then, they make a tiny, standardized puncture, and boom, the stopwatch starts. Every 30 seconds, they take a little piece of filter paper and just gently blot the blood. Now, the key here is not to actually touch the skin, because you don't want to mess with that plug that's trying to form. The second the paper comes away clean, they stop the watch. And that's it. That's your bleeding time. Simple, but actually really clever. Okay, so we know how it's measured. But here's the big question. So what? Why does it even matter if this time is too long? Well, this is where a simple test like this becomes a really powerful tool for doctors. To put it as simply as possible, a prolonged bleeding time is a huge red flag. It's a clear signal that something's not right with those first responders, that initial platelet response is failing somehow. So, what could be causing that delay? Well, there are a few possibilities. Sometimes it's just a numbers game. You literally don't have enough platelets. That's a condition called thrombocytopenia. Other times you've got plenty of platelets, but they're defective. They just aren't doing their job right. And sometimes it's not even about the platelets. The problem could be with the blood vessel walls themselves. Conditions like von Willebrand disease, or even just a really high fever, can also slow this whole critical process down. Okay, now to really nail down the difference between bleeding time and clotting time, we're going to look at a classic medical case. It's the perfect example that highlights exactly what we're talking about. So, let's go back to our analogy for a second. Is it possible for the first responders to show up, do their job perfectly, but the repair crew just never shows up? Could you form that initial plug just fine, but then completely fail at making the final, strong clot?
The answer is absolutely yes. And the classic example that proves it is hemophilia. This is the key that unlocks the whole puzzle.
And this right here is where it all comes together. Look, if you have a platelet disorder, the first responders are faulty, so your bleeding time is going to be long. But the repair crew is fine, so your clotting time is totally normal. Now flip that. In hemophilia, it's the complete opposite.
The platelets, our first responders, are working perfectly, so the bleeding time is normal. The problem is the repair crew. The clotting factors are faulty or missing, so that final clot just doesn't form right, and you get a dangerously long clotting time.
So the big takeaway here is this. Bleeding time and clotting time are not the same thing. You can't swap them. They are two totally separate tests looking at two different but equally crucial stages of how your body stops a bleed. One checks the paramedics and the other checks the engineers. You need both to work.
It's pretty amazing when you think about it. This is just one of the countless totally invisible timers that are always running inside of us, keeping us safe, and we have no idea. It really makes you wonder, doesn't it? What other life-saving timers are running in our bodies right now?